A tree is a nice thing. Trees remove carbon from the air, we know that. Trees bear fruit or nuts for us to eat. Trees provide shade, allowing other crops to grow around them. But trees also redistribute water and keep rivers running, enrich the soil and landscape around them, and stabilize their environment. But we tear them down anyway. And it's having an impact on the environment. Deforestation, largely driven by agriculture, is now the second leading cause of climate change after fossil fuels. And Ecosia is doing something about it. Ecosia is the search engine that plants trees. And like all search engines, we give you web search results. But every search with Ecosia removes 1 kilogram of carbon dioxide from the air. When our users make a web search, we show ads next to regular search results, just like this one. Every time a user clicks on one of these ads, we earn some money. Unlike any other search engine, though, we use the money that we make from these ads to plant trees by supporting reforestation projects around the world. Wait a minute. An internet startup that uses its profits for good? I mean, an internet startup with profits? How does this make sense? It's honestly really simple. We earn money like any other search engine. We use it to plant trees. And we're getting really good at it. As of this morning, we've planted nearly 43 million trees, and we plant about 1 tree every second. At this rate, early next year, we'll plant our 50 millionth tree. We plant these trees where they're needed most, in biodiversity hotspots around the world. These hotspots are places with more than 1,500 native species of vascular plants that don't exist anywhere else in the world, and where 70% of the natural vegetation has already been lost. Our trees are currently being planted in 12 of these biodiversity hotspots, employing thousands of people. In some cases, the trees that we plant are jointly owned with a local community, meaning they can create an economy for themselves with the produce gathered from the trees, like mangoes or avocados. And in addition to helping communities, our trees have so far removed 2 million tons of carbon dioxide from the atmosphere. And I just want to show a short video showing the tree planting work we're doing in Tanzania and how our trees have helped to redefine the landscape there, so you can get an idea. So, who am I, and how do I fit into this? I'm Jason. I like trees, but to be honest, I mostly like distributed systems and incident response. And after shortly working, these are all jobs that I did used to do. After working as a jazz musician and an Apple Store genius, I ended up in Berlin. I'm originally from Canada, and I work as a software developer, a back-end developer, but I mostly focus on infrastructure. And I'm curious, how many people look at a graph that looks something like this every day? Probably more people than that. Monitoring? No? Okay, a few people. I mean, I do, for sure. At Ecosia, we have lots of monitors for request rate, for latency, resource utilization, error rates, stuff like this. But this is not one of those graphs. Does anybody have a guess what this graph is showing? Yeah, this is trees per second in estimated real time. We monitor this because it's what matters to our users. That's what our users care about, that we're planting trees. And this laser focus on our mission leads to some really interesting requirements all around the company. As you can imagine, the more money we spend on running the company, the less we have for our tree planting projects. I know all companies, especially startups, care a lot about how much money is being spent, but in our case, our expenditures can literally be measured in trees. For example, I've had a lot of fun at this conference. I love being in Galway, and I'd like to be able to come again. So to justify it, it would be great if lots of you could start using Ecosia in your browser. And our users do hold us accountable. By releasing public financial reports, we let our users make sure that as a company we behave in a responsible way that's in line with our values. This means having enough developers to do the technical work we need to do and that we want to do, but also staying lean. In addition to running the Ecosia search service and, like you see, spreading the word about it and obviously the tree planting, we also save up money so we can occasionally do things like try and buy a forest to save it from being torn down. So this is a report from The Guardian from about a month ago when we offered RWE, which is a German energy company, 1 million euros to try and buy the last remaining piece of the ancient Hambacher forest. The energy company was planning on tearing down the trees to do coal mining like they've done with the whole rest of the forest. They declined our offer, but we and our community are still hoping that we can keep the forest from getting torn down for coal mining. But okay, enough about trees. What does any of this have to do with DevOps Days? How do I, an infrastructure engineer, fit into tree planting? Well, all of that stuff that I've just mentioned becomes part of the requirements for our development and our operations strategy, all of our technical work. When users install our browser extension, or in some other way configure their browser to search with Ecosia, they have some expectations about how a search engine behaves. They definitely have some expectations about how reliable that search engine is. You could say how the search engine's site is reliably engineered. But our users also need us to respect their contributions and put most of our income towards our tree planting projects. So a big developer team or even a dedicated SRE group is not really in the cards. So we develop and maintain Ecosia Search for our millions of users with a team of about 10 developers, only 2 of which focus on infrastructure. This provides some interesting and challenging constraints to how we can run DevOps. For example, these 2 infrastructure-focused developers, well, one of them is here on this stage, and luckily for me, the other one is on call. After a while of operating this way, the infrastructure-focused developers, we realized that doing operations like throw it over the fence was not going to work. There was too much to be done between maintaining a platform, being on call, for us to also be doing production reviews and writing everyone's deployment configurations. The easiest way to demotivate an infra developer is to make them write YAML configurations all day, even cool YAML like Kubernetes. So we definitely did is we looked at our favorite aspects of DevOps and SRE, we made a year-long transition plan, got all the stakeholders involved, and set clear transition goals. No, you don't believe me, do you? We did none of that. Not at all. What we did is we started to look at how our team was structured and the work we were doing and how we could make it fit a little bit better together. So the beginning of our solution was for the infrastructure-focused developers to embed ourselves in the product development teams. This helped us find the pain points in the development workflow, and it gave us firsthand knowledge of what we should be automating. But it didn't really reduce the operational work. We still needed to find a way to reduce the toil and get back to coding. So now, the infrastructure-focused developers split our non-toil work between infra tasks and normal dev work. You see a much more balanced split now. But we also changed our responsibilities across the whole team to more evenly share the load of toil between the infra developers and all other developers. But then who maintains the platform and the tooling? And I'll get to that in a bit. As infrastructure-focused developers, we created a special interest group, a SIG, which is an opt-in group of developers from across both product teams that are in charge of running the platform. So the platform can't be owned by one of the product teams because we have cross-functional product teams. All the products are running on the platform. So this special interest group owns and maintains the platform. Which sounds really nice. But if you don't believe me yet, let me show you a little bit more about how we did it. So the way we architected our teams is, like I mentioned, cross-functional product teams. So we have teams that focus on areas of the application, areas of the product. So the search service, the browser extensions, the information about Ecosia. Now, within those teams, we have the infrastructure-focused developers like me, embedded in that team doing some of the SRE and DevOps kind of work. And then across both teams, we have the special interest group, which is owning the platform and the tooling. We share the responsibility, all the toil, between the developers and all developers and the infra developers. So all developers take a turn of daytime on call. As we heard earlier, we know that the vast majority of incidents are going to happen during the daytime when code changes are being rolled out. So by bringing developers into the on-call schedule, all the developers now get the benefits of learning from incident response and learning how their applications are behaving in production. And the infra developers maintain the out-of-office hours on-call. Now, all the developers also write their application configuration and deploy their applications through a pull request CI/CD-based pipeline, which again sounds really nice, but trying to get an application developer to write configuration might be a little bit difficult. So as infra developers, we maintain the platform, but we also are writing tools to make it easy for all developers to be deploying, and we try and advocate for SRE culture everywhere. Now, we're trying to accelerate what's possible for all the application developers, so we need to choose the right technology to make it possible to integrate all of our tools and technologies and languages into our development and production environment. So we chose our technologies very carefully. We really like using Basil for our builds. Basil is a language agnostic build tool, so we do builds for all our different applications through Basil. We also build our manifests for Kubernetes through Basil using a programming language called JSONet, which is a superset of JSON. So it's a way to write JSON or also YAML configuration, but as code using libraries and functions. And then we host all of our applications on Kubernetes, which to me is a developer-focused platform. It's a way that we can treat, sorry if the slides keep cutting up, by the way, intractable problem, apparently. But yeah, so Kubernetes is a way for us to look at infrastructure the way developers like to, by writing, especially when we combine it with JSONet and templating our configuration, we can code our configuration. Now, you might be noticing Basil is an open source project by Google. I understand that Googlers internally know it as Blaze. JSONet is an open source programming language by Google. And Kubernetes, you might know, is an open source community project that was kickstarted internally as based on Borg at Google. So I understand that Google knows a thing or two about running search engines at scale. So, search engines of a feather fly together. We also streamlined our testing and QA process by introducing per-branch deployments. Previously, there was a few staging environments that people could deploy to, and developers would take their turn deploying stuff onto the testing environments, getting QA on new features. And when our developer team grew, when our developer team grew from 3 developers to 10 developers, so more than tripled in size, it wasn't practical to share test environments anymore. We now had multiple features that needed to be tested or QA'd at the same time. So our new per-branch deployments are created simply by opening a pull request. Our CI pipeline then creates a namespace in Kubernetes, so an isolated set of resources. And similar to Frank's talk yesterday about blast radius, Basil has a query functionality which will find out which files and which builds are affected, so that we can simply find out which applications in our mono repository need to be deployed for that pull request, and then deploy exactly that application or applications. And the nice thing is Basil lets us make our CI pipeline 100% replicable locally because it's just running the same commands we would. That makes it so that we can roll back really, really fast. This is a screen grab from my favorite website on the internet, outage.party. This is also a screen grab from outage.party. And this relates, I think, really well. When we adapted a culture of calculated risk and no blame postmortems, It meant that developers can own their own deployments. All developers are involved in the process of monitoring applications, which comes in really handy when they take their shift as part of the daytime on-call. Now, I'm going to attempt a little bit of a demo so I can show you how we put the pieces of Basil and JSONet together to write some Kubernetes configuration. Before I do, how many people are already familiar with Kubernetes or have ever used Kubernetes? Wow, that is such a big change from a year ago. That's most people. For anybody who didn't put up their hand, Kubernetes is a cloud orchestration system which allows you to put many compute nodes together and then run Docker containers as services and handle all the networking. So I'm going to switch over. Well, I'm going to walk over here first. Can you still hear me okay? Yeah, good. Okay. Switch over to some code. So here I have a new Go application that I want to deploy. And so I've written the source code in main Go. I haven't written any tests yet, but I'm sure I will. And I'm going to start by creating the project within our Basil mono repository. So this is just a directory within a larger repository. And I can sort of bootstrap it with Basil init, Go, and then the directory that I want to bootstrap. Now this is a sort of very simple plugin that we wrote on top of Basil. And this is going to create a couple files. Namely, it's going to create a Basil file, which allows us to specify the targets. But because we're using Go, it can be pretty well automatically generated. And it's also going to create a JSONet file in which we will define our configuration using a template. So the first thing I can do now that I've created this is I can try and run the application using Basil. So I can just simply do Basil run, and then the name of the directory. And it's now started that Go server. I can switch to my other terminal. Sorry, it's got a little bit small, so you can't see that it's listening on 8,000. Curl, amazing. This is a hit product, I'm sure. Now I go back to my first terminal, and I'm done with development. I'm really happy with the way this product is working. And now I want to ship it. I want to deploy it. So I'm going to test my configuration. Well, first I'm going to look at my configuration, which is probably the best idea. So let's open up demo/demo.jsoned. So in this file, you see we import a shared library, which has a bunch of predefined application configurations that we can use for all different sorts of applications. All we need to do is plug in the Docker container that we built with a different Basil rule, and we can turn this into a whole set of Kubernetes configurations really easily. So I'm just going to simply call Ecosia kube cluster application. Now, in our terminology, a cluster application is something that only is served internally in the cluster. So it doesn't need traffic routed from outside. It's kind of an internal service, which I think is fine for this application I'm writing. And then at the very bottom, you see we have effectively a raw JSON document. Every JSONet file outputs JSON itself. So we end the file by passing through the deploy collection from this particular object. So now I can run Basil deploy demo. I do have to provide an environment. So let's deploy it to our development environment. You can see here I'm on the branch, my initials, DevOps Day talk. And what's happened is it spit out a whole lot of configurations. So I'm going to go back up to the top and we can just go through. So the first thing it creates is a namespace in Kubernetes. That's an isolated resource. It means that when we close the pull request, or sometime after it's been open, we can tear down everything that was associated with this branch in one step. We just remove the namespace and everything gets torn down. We also add a quota on resources so that one particular pull request that changes a lot of different applications, and therefore we have to deploy all those applications together, doesn't starve off our whole cluster. Then we have our deployment object. This looks really long, but you see I didn't write any of it. This is all predefined because it's pretty much common usage across all of our applications, all of our simpler ones. JSONet makes it really easy to override, the same way I did here with port. Obviously, not every application uses the same port, so I just override that port value. And that gets interpreted in a few different places. But this deployment is pretty standard. We usually, we have a pretty standard attitude towards the rolling update strategy, so how many new replicas we want to start versus old ones we want to tear down during a rolling update. It's obviously different for development and production. And then we interpolate the Docker image that we just built. So that was all done in one step. When I ran Basil deploy, it was a Docker image was built, a Docker image was pushed to our remote repository, and the SHA of the hash of the Docker image itself gets interpolated into this configuration. And we scroll through some more. You see there's the port showing up here so that the pod, the Kubernetes pod, knows that that port's been exposed. And down at the bottom, we have a service which will give the other applications in the cluster a DNS host name so that they can reach this service. So you've seen in, like, I don't know, here, 12 lines of code, of which I didn't actually write any. We now have a whole service deployed in our cluster, ready to test in our per branch namespaces. And when I want to deploy to production, all I need to do, if I'm somebody who has production credentials, just change this dev to prod, and then we're ready to go. That'll generate the production templates, but I'm ready to deploy this. I don't want to just look at the configuration. I want to actually send it to the cluster. So I just add .apply, and it's going to send this into our development cluster and create all these objects that we just talked about. This is something that all developers can do. So our goal, as the infrastructure-focused developers at Ecosia, was to design a system like this so that any developer can run a couple of commands, create a, bootstrap a whole new application, and get it shipping really, really fast, and they can own the whole thing end to end. Can't believe that worked. Okay. Remember this graph from the beginning? Oh, now I need this. There we go. Remember this graph from the beginning? I told you it was trees being planted in semi-real time, but this is actually user behavior. So this is an estimation because we track user behavior through Kubernetes and Nginx ingress. We collect that data through Prometheus, and we visualize it using Grafana. This sounds exactly like infrastructure monitoring to me. And while it's not an actual measure of trees going into the ground, it's a projection of trees that we'll be able to plant because of what's happening right now. And that makes it a good representation of whether or not our systems are healthy. If our systems are healthy, users are behaving in the way that we want, they're being able to accomplish what they want, which in general is searching, and we know for the most part that we're working okay. Working on infrastructure can often be so abstract that I find it really valuable to tie our system's health back to something more tactile, more tangible. It also gives developers a lot of pride to see the impact on the environment that our software is having. As an example of the impact our software is having, I want to show you this short video of Almaz, a woman in Ethiopia, who's going to tell her story about tree planting and growing coffee. It's amazing to think that the work we're doing on silly things like platform stability and cost optimization can contribute to something like this.
After we planted the forest, the river came back. Its banks are full of water, even in the dry season. My name is Almaz. I'm from Safa in Ethiopia, and I have 2 children, 2 hens, 2 goats, and 1 husband. Before planting the trees, I collected sand from the river for 20 cents. It was hard work and dangerous too. But my life is different now. With other women in my village, I am planting a forest on communal land. Thanks to the trees that Ecosia and Green Ethiopia have provided, our fields have become more productive. Collectively, we were able to save almost $500. We kept track of our savings in a little book. Before, we hardly had any savings at all. Some families did not even have enough food, but now we can all send our children to school. On my farm, I grow coffee and bananas. Since I planted the shade trees and fruit trees here, my yield has improved because the sun no longer dries out the soil. Every year, I harvest more coffee than before and sell it on the market. We want to continue reforesting our land. Us women are pioneers. With your support, we have improved our land and the lives of our families. If you don't forget us, I know that we will continue to see change. It will be outstanding.
Thank you very much for listening to our story. If you want to get an Ecosia sticker for your laptop or just chat about your favorite tree, come and find me or tweet at me. I'll be around this afternoon. Thank you so much for listening.